Today in pre-calculus, I was asked to show that in any given triangle A, B, C, that the tangent of A plus the tangent of B plus the tangent of C equals the product of all the tangents. And I was thinking, what's special about this? It only works, they say, when A, B, and C are all angles of the same triangle, this triangle. And that just means, I guess, to put it in another way, is that A plus B plus C equals, they add up to 180 degrees. And this is pretty special, I think. So one way to simplify such a weird problem like this with 3 variables, let's try to make it 2 variables. And to do that, we know that there's a special thing. We can just rewrite, let's try to get rid of this tangent of C. So we can rewrite this C as just if you move A plus B to the other side, or if you subtract A plus B from both sides of this equation, we get C equals 180 minus A plus B. Oops, there we go. Minus A plus B. And this is kind of special because then we can rewrite this tangent of C in the same way. So, well, the tangent of C is just becomes the tangent of 180, 80 minus A plus B. And what's special about this 180 minus any angle? Well, we know just off to the side, in any circle, right, if this is like a unit circle, that the tangent, let's say this was an angle, like alpha, and this was 180 minus alpha, because subtracting alpha from 180, right? The thing is, the tangent, or the slope of this angle, is basically the opposite of this slope, of this angle, right? So basically, the tangent of 180 minus alpha, this right there, this slope, is the opposite of the tangent of just alpha. So that can just be rewritten as the tangent of 180 minus something is just the opposite or negative tangent of that angle, A plus B. Okay, so that's just part in the handwriting right there. So this is just equal to minus tangent of A plus B, right? So then, now what? If we just replace this back to the first equation, we can rewrite this. Now, tangent of A plus tangent of B. This time you subtract the tangent of A plus B. And of course this equals to the product of the stuff. B tangent of C, whatever. Let's just keep this side that way. It's an identity. We're only working with this side. So, now that we've got this done, well, not done, now what? Well, let's just simplify this first, this tangent of A plus B. Using our trigonometric identities, we know that this part is equal to tangent of A plus tangent of B over 1 minus the tangent of A times the tangent of B. And we know that because it's a trig identity. We can prove it later if you want. One way to memorize this is just saying tan over 1 tan. You know, the bottom subtraction is opposite to whatever's being done here. Anyway, and then we can rewrite the next part. So tangent of A plus the tangent of B minus this. Right? Now what? Well, one thing to recognize is that there is a tangent of A plus tangent of B right there. And over here, there is also a tangent of A plus a tangent of B. How peculiar. Well, if we just take, well, since these two terms have the same factors, we can just factor them out, this whole thing. So let's just rewrite this again as tangent of A plus the tangent of B. And this whole thing times tangent of A minus, this is just, if you divide this by the same thing, it's just 1 minus, and then divide this by tangent of A plus tangent of B, it just becomes 1 over 1 minus tangent of A, tangent of B. Whoops. So, now what? Well, we've got some things going on here. I would like these two terms to have the same denominator, just so that things could be a bit more neater. So let's just quickly simplify. Whoops. Tangent of B. Multiply this by, and then just get these two terms having the same denominator. That's all. So 1 can be rewritten as 1 minus tangent of A, tangent of B, over 1 minus tangent of A, same thing, tangent of B, pardon my handwriting, minus 1 over the same denominator, 1 minus tangent of A, oops, tangent of B. And close that off. Now what? Well, if we just simplify this, there's 1 and a minus 1. We can cancel out the 1's until it just becomes a minus tangent A tangent B over this denominator. So then, let's just write that again. So we got tangent of A plus tangent of B over times, then we got minus tangent of A times the tangent of B divided by 1 minus the tangent of A tangent of B. Now, it doesn't look that bad actually. It looks like we're getting closer to what we want. See, we have a tangent of A times a tangent of B here. Well, if we already have a tangent of A times a tangent of B, everything else in this term should be equal to tangent of C, if that's what we want, right? So let's just isolate the tangent of A and tangent of B, just put them off to one side, and then put everything else together. So let's just put this denominator, we can move this to divide this instead of this, and this negative sign, let's just put it over there, right? So let's simplify. Let's just, I'm just gonna remember this, I'm just gonna move pages. So now, we can say that we can rewrite this as the tangent of A equals tangent of A plus the tangent of B. If we move this denominator right over there, we get, just put this over 1 minus the tangent of A times the tangent of B. And also, if we're going to move the minus sign, right? Just add the little minus sign. Just move that little minus sign there. So, and then after that, just times that by tangent of A times tangent of B. I can smell the victory. We're very close. So, now that we've got this, just temporarily ignore the minus sign. Now what have we got here? We've got tan over 1 tan. Huh. So this is just the angle sum formula for tangent again. Well then, that's quite good. We can just rewrite this again as tangent of A plus B, right? And then just stick that minus sign at the end, because it's still multiplying this. And then times the tangent of A times the tangent of B. Cool. But then, what's this again? This seems familiar. If we go back, if we recall right here, that we said the tangent of C is equal to the negative tangent of A plus B because triangles. Huh. Cool. So then we can just rewrite this part as the tangent of C then, right? Times the tangent of A times tangent of B. Just rewrite that one more time. Shifting some things around. Commutative law, mate. Tangent of B times tangent of C. And we are done. The key was that A plus B plus C sums up to 180, hence the triangle. So there we go. A seemingly strange problem, like how? With this, just the sum of three things is equal to the product of three things. Well, it works here for any a plus b plus c that add up to 180. Interesting.